Elementary maths foundations concern counts, measures, and relationships between quantities that reveal predictable patterns, and counts of absolute value binary operations. The role of 0 as a number, defined by Brahmagupta as the sum of equal yet opposing positive and negative quantities, was neither grasped in the Middle East nor transmitted to Europe. So we can see in India in the year 628 the transmission of 0 as a placeholder, yet not as defined by Brahmagupta in the year 628, began. So the 0 as a placeholder began in India and then went to the Middle East, to Iraq, to Baghdad, where Al-Khwarizmi investigated Indian mathematics and wrote a book about Hindu arithmetic. And that was in the 9th century, about 200 years after Brahmagupta. From the Middle East, it went to North Africa and then to Italy with Fibonacci, and then to Robert Record in England. But I can imagine that Robert Record might have said, Brahmagupta, I wasn't told about your 0 definition or your 18 sutras of 0, positives and negatives. So neither negatives nor 0 appear to have been involved in the development of Arabic algebra. But first, some ballet. Notice the way she is spinning. Which way is she spinning? Answer in the chat box. Just type in your answer. Is the dancer spinning right and clockwise, or left and anti-clockwise? Type your answer in the chat box. Like mathematics, she spins both ways, right and clockwise, and left and anti-clockwise. And there you can see the same image clearly presented to your brain, spinning in 2 different directions. So our mind will perceive mathematics in a way that is unique to us. And yet we have seen the evolution of mathematics happen only towards 1/2 of our foundations. That's what happened in the West. So complete the phrase. Answer via the chat. For every action, there is an... What do you think it might be? Type it into the chat box. Equal and opposite reaction. And that is Newton's 3rd law of motion. So actions have equal and opposite reactions. Let's look at 1 negative electron plus 1 positive positron. Together, they equal to 0. They annihilate each other and release a little bit of energy in the form of a photon. Now, symmetry, the heart of Indian mathematics, symmetry is when things are the same around an axis. Seeing symmetry and discerning when it breaks is a key for understanding both mathematics and physics. Imagine a big bang, which would have been silent in space. Nobody can hear you scream. But it's as if shunya was decompressed, creating infinite magnitudes and multitudes from zero. And from the Big Bang, we can consider the zero-sum universe, the conservation of matter and energy, and Newton's third law. And from the foundations of mathematics of Brahmagupta and Bhaskara and symmetry emerges my own mathematics, Podometic, which is an update or a replacement for arithmetic. So consider planet Negatron off to our left, or is it off to our right? And consider planet Positron. And in the middle, in that static view, if there's a body between them equidistant to both planets, there is zero gravity upon that body. So wherever opposing quantities or forces or directions are equal, you will find zero. So here we have a simple number line with a smiley 0 mediating in the middle between two opposing multitudes and magnitudes. Now we need to consider in our framework of mathematics, in our meta-mathematics view, our bird's eye view of the foundations of mathematics, what I call the 0-point choice. Now here we have Escher's artwork, which I've put a couple of straight edges into the artwork. Now, when we draw a point, we need to make a decision from that point, using our straight edge, which way do we draw our line? We can draw our point in two opposing directions with our straight edge. We might have our point and then draw our pencil off to the right, or we might have our point and draw our pencil off to the left. And both of those directions can be equal and yet opposite, just as if you walked east and then you walked west. So from an arbitrary point, which direction do we go? Well, the west says we only ever go off to the right, and we call that direction positive. And yet Brahmagupta's ideas were not applied 1,000 years after the time of Brahmagupta in the 7th century. And yet those ideas should have been applied, because Brahmagupta's ideas were about symmetry. His ideas of mathematics were empirical, based on scientific observations of how the universe worked. Yet the ancient Greeks, they based their mathematics on philosophy, and from the philosophy emerged a geometry, in which they didn't have 0 or 1 as numbers, and they didn't have negative numbers. So 1,000 years after Brahmagupta, we had René Descartes. And it's from Descartes that we have the Cartesian plane today. And yet the Brahmaguptan plane is superior. So Brahmagupta's 5 Addition Sutras are pretty much what you would expect them to be. No surprises there. And yet the zeros and negative terms are in 4 of Brahmagupta's Addition Sutras. And what we will find out if we explore the sutras a little more is the word negative, positive, and the word zero, they appear so often in the definitions that the sutras, the laws of Brahmagupta from the year 628. We have subtraction, we have multiplication, we have division as well as the Addition Sutras. And on the screen, we also have Brahmagupta's original Sanskrit. Now, we look at Addition Sutra 4, and that is the magical element of mathematics that got lost when Brahmagupta's zero went to the Middle East on its way westward. Addition Sutra 4, when positive and negative are equal, the sum is 0. So here, let us imagine that we've got one black positive and we've got one red negative. So when the positive and the negative are equal, the sum is, as you can see, 0. If we've got 2 positives and 2 negatives of the same size or multitude, again, the sum is 0. So 0 can either be an absence of everything, or it can be the sum of everything. So we have taken away 2 positives, 0 minus 2 positives. What do we see? 2 negatives. From 0 again, this time we will take away 2 negatives. 2 red negatives go away. 0 minus 2 negatives leaves 2 positives. So when positive and negative, when positive and negative are equal, the sum is 0. So imagine this line is ground level 0. We can add integers to 0, and by integers, I mean the positive and negative whole numbers. We can add integers to 0, and here I've created the B line, a Brahmagupta version of our number line, which has implicit symmetry in it based on his Sanskrit shlokas, his sutras. And so off to the right, we can see we've got counts of positive units, positive black ones. And to the left of the 0, we have counts of red negative units. And it doesn't matter whether black is positive or black is negative. Whatever we choose, the other number will be the opposite, an opposite color, and together one of each or two of each or infinity of each will all sum back to Brahmagupta's 0. So just as we can add integers to 0, we can also subtract integers from 0. And as we saw before, whenever we subtract one integer, one color from 0, it results in the opposite color. Whenever we subtract positive from 0, it results in negative. Whenever we subtract negative from 0, it results in positive. So we can put together both the addition and subtraction of integers, and we get this symmetric pattern, where off on the right hand side we have addition of positives and we have subtraction of positives. Subtraction of a positive will give you the negative, remember. So that's why there are opposite colors on the right hand side of the midpoint 0. And on the left hand side we have addition of red negatives and we have subtraction of red negatives. Subtraction of red negatives will give you positives. So now we can apply the Indian logic to Descartes' multiplication. And this diagram is from 1637, and this is the first diagram that led to the development of the Cartesian plane. And this is in French. And as you might have guessed, René is a French name. So let me read the translation. And we've got the diagram with two lines, the axes. Across the bottom, we can consider it an x-axis, and going up to the left, we can consider that a y-axis. But let me translate the words of René Descartes. For example, let AB be taken as unity, or 1, and let it be required to multiply BD, the multiplicand, by BC, the multiplier. I have only to join the points A and C and draw DE parallel to AC, and BE is the product of this multiplication. So let me make this a little simpler with an electronic version. So here I have a GeoGebra app, and you can see the web address, so you can play with this yourself. So what we have, if we look at the legend, we have BD across the bottom in blue is the multiplicand, and we have BC going up to the left is a green line for the multiplier, and then we have BE is the product. Now, if I just extend out the multiplicand, we see that, which is the blue line, we see the red line, the product, increases. So I've extended the blue line, and as you can see, the red line has increased. If I reset it again, this time I'm going to extend the multiplier, the green line, and we will also see the product increase. So we have increased the green line, and through the property of similar triangles, we can see that the product has increased as well. So let's reset again, and with this geometry, we now introduce the concept, the point choice I mentioned before. So we can say, let 0 appear at point B, and let a line drawn to the opposite side of B be negative. So now we can have a negative multiplicand and a negative multiplier, and we see together they both produce a positive product. So a negative multiplicand and a negative multiplier results in a positive product. Now this should have occurred to Euclid in 300 BCE. This should have occurred about 2,000 years later to René Descartes, but it didn't. So here we have another applet which is on the standard XY Cartesian plane, and I invite you to play with it so you can see the relationships between the similar triangles and the geometry of both positive and negative line segments. We also have another applet for division, because proportion works for both multiplication and division, and importantly, proportion is preserved across both negative and positive. And yet all of the proportion theory that developed in ancient Greece only dealt with what we would say today are positive magnitudes. So let's look at Al-Khwarizmi's 6 equation types. Arabic algebra entailed steps to arrive at co-equal polynomials. So the following is an anachronistic styling as modern equations. But Al-Khwarizmi didn't have equal signs or exponents written like this. So we have, for example, ax squared equals bx is an example. We have ax squared equals c as an example. And you might have heard about Al-Khwarizmi's technique was balancing equations. And if we just imagine a pan balance like this, you can imagine ax squared is balanced with bx, or ax squared is balanced with c. Or what about bx is balanced with c, and ax squared plus bx is balanced with c? Now, what you might have noticed is that what's missing is a polynomial in the form ax squared minus bx equals negative c. How could you have a positive term on the left of that balance pan equal to a negative term on the right-hand side? The Arabic world and Al-Khwarizmi never understood Bharat's algebra, which encompassed both zero and negatives. We also never had an equation come out of the Arabic world such as ax squared plus bx plus c is balanced against 0. You can imagine a set of balance scales would never make any sense in this form, and it didn't emerge in the Arabic world. And so let's consider Al-Khwarizmi. What did he say? Let me say, I had seen that the Indians had set up 9 symbols in their universal system of numbering. 9 symbols? And every number put together above 1. So Al-Khwarizmi did not mention 0. 1 is the root of all number and is outside number. It is the root of number because every number is found by it. But it, 1, is outside number because it is found by itself, without any other number. So Al-Khwarizmi did not mention 0 and did not consider 1 a number. So what if we move from al-Khwarizmi to al-Yuqlidisi about 150 years later? And he says in his book, why are the Hindi letters 9? So much for the 9 letters. 0, the aim is only to occupy the place. We multiply the letter to occupy the place. Tell that there is a place and that it is empty. Now, these are key phrases. There's much more in between them. But what we find is that our Euclidesi considered 0 an empty placeholder and not a number. And that's again because from India, we had the transmission of 0 as the placeholder, yet not as defined by Brahmagupta. India's 0 concept as a wonderful concept that embodies 0, positive and negative. Well, the concept of the 0 and the negative seemed to have vanished to nothing on its trip to the West. So we must fix maths. And the way that we do this is to have independence from the British. Because the British Empire is their mathematics. It's Greco-Anglo. It's Greek and English mathematics, built without 0, without 1 as numbers, and built without a concept of symmetry with positive and negative mediated by a 0. And the British math that they spread throughout the colonies and settlements of the British Empire was only built for 1, 2, 3, and so on. So we must simply Brexit British maths myths and rediscover Bharatiya 0-built mathematics with the beautiful symmetry. Off to the left we have 0, 1 negative, 2 negative, 3 negative, off to negative infinity. And off to the right we have 0, we have 1 positive, 2 positive, 3 positive, off to positive infinity. So if we look at arithmetic, which is what developed in the West, we can see that the child's mind is obscured because the ideas of index laws and multiplication makes more, negative numbers, it's all about rules, not reason. The integer ordering is wrong. The number words make sense. The laws of sign are wrongly explained. And we find that children around the world do not like Western arithmetic. They fear it and they fail it. And sometimes they enjoy it. But wouldn't it be wonderful if, having rebuilt Bharat's beautiful mathematical foundations, that Narendra Modi brought about the revival of a mathematics I call Podometic, which is Bharatiya mathematics. So the child's mind, the maths mind of the child, is illuminated fully with common sense, multi-sensory games, fun, songs, toys. It's intuitive. There are stories. And children love Bharatiya mathematics. And so we must now accept that the mathematical foundations of ancient India are true and the mathematical foundations of the British Empire are false. So now you know. Arithmetic is based on ancient Greek ideas. It arose before India invented 0 as a number. The ancient Greek math was 1,000 years out of date by the time Brahmagupta wrote his sutras. So the evolution of elementary maths is beginning again. Thank you. This has been Jonathan J. Crabtree.